Hello students, welcome to this lecture on surface areas and volumes. So in this lecture, we will discuss NCT exemplars problem on surface areas and volumes. Okay, so let us start. So in first number question, here we have a cylindrical pencil sharpened at one edge is combination of what? So do you see a cylindrical pencil? Okay, sharpened at one edge. So if you see the cylindrical pencil, then you can see like this. Okay, this is our cylindrical pencil, and serpent pencil is the shape of the serpent pencil is like this, and this solid actually this cylindrical pencil serpent at one edge is the combination of cylinder and cone. Okay, so this portion is cylinder and this portion is cone. So you can divide the shape of serpent pencil into two parts. One is cylinder and other is cone. Okay. And now let us move to next question. So in next question here we have Surahi is the combination of what? In option A we have a sphere and a cylinder. In option B we have a hemisphere and a cylinder. And in option C we have two hemispheres. In option D we have a cylinder and a cone. Okay, so among these options, which options is correct, that we'll have to find here. So here let us see how to find. So Surahi look like this. Okay, so Surahi look like this. So because of the shape of Surahi is like this, so we can now divide this shape as an sphere and a cylinder. Okay, so Surahi basically the is the combination of a sphere and a cylinder. Okay, and in option A we have a sphere and a cylinder. So option number A is here correct answer. So option number A is here correct answer. Now let us move to next problem. So in next problem here we have the a plumbine. So that is also known as Sahul is the combination of what? So you can see the figure and you can easily say a plumb line is the combination of what? Okay, so here we have given four options. So in option A we have a cone and a cylinder. In option B here we have a hemisphere and a cone. In option C we have frustum of a cone and a cylinder. In option D we have sphere and cylinder. Okay, so among these four options, which options will correct, that we have to find here. So let us see the answer. So plumb line look like this, and now if we divide this shape into two parts, okay, so you will get one hemisphere and cone. Okay, so you can write this shape as a hemisphere plus a cone. So this a plumb line, that is also known as Sahul, is the combination of a sphere, hemisphere and a cone. Okay, so the here option A is correct answer. Okay, so for this question, option number option number B is correct. So option number B is said a hemisphere and a cone. So a plumb line is the combination of a hemisphere and a cone. And now let us move to next problem. So in next question here we have the shape of a glass tumblers. You can see this figure. So is usually in the form of what? So you can visualize this shape. So this is actually shape of a glass. Okay, so here you know that the shape of the frustum of a cone is look like this. Okay, and so the given figure is usually in the form of frustum of a cone. Okay, so this is the frustum of a cone. So the shape of a glass tumbler, that is known also tumbler, is usually in the form of frustum of a cone. Okay, here option number B is correct answer. And now let us move to next problem. So question number 5. So the shape of a gilli in the gilli danda game. Do you know gilli danda game? Okay, so actually we here ask what is the shape of a gilli? Actually, what is the combination of shape of a gilli? Okay, so let us see. what are the combinations of this shape. Okay, so let us see. Here you can see this is actually combination of two cones and a cylinder. Okay, so at ends there are two cone, and in middle we have a cylinder. So therefore the shape of a gilli is a combination of two cone and a cylinder. Two cones and a cylinder. So option number C is here correct answer. Okay, students. And now let us move to next problem. So in next problem, here we have a shuttlecock used for playing badminton has the shape of the combination of what? So look, first of all, see the, you see the, you have seen the shuttlecock that is used for playing badminton. Okay, so because the shape of the shuttlecock is equal to the sum of the first term of a cone and hemisphere. Okay, so a shuttlecock used for playing badminton has the shape of the combination of first term of a cone and a hemisphere. So here correct answer is option number D. Okay, and now let us move to next question number 7. So a cone is cut through a plane parallel to its base, and then the cone that is from one side of that plane is removed. The new part that is left over the other side of the plane is called what? So we have given this 4 options. So among these 4 options, here we have the following situation is called what? So here let us see the figure. So here the following situation can be drawn by this figure. Okay, can be represented by this figure. So here actually a cone sliced by a plane parallel to the base. Okay, and if we slice this cone by a plane parallel to the base, then it get the shape look like this. Okay, so the two parts are separated, and we get actually first term of a cone. Okay, when we remove the upper portion of the cone cut off by plane, we get first term of a cone. Okay, so this must be recalled. When we remove the upper portion of the cone cut off by plane, then we get first term of a cone. So here the correct answer is a first term of a cone. Okay, so correct answer is option number A. And now let us move to question number 8. So in question number 8, here we have if a hollow cube of internal edge 22 centimeter, okay, 22 centimeter is filled with spherical marbles of diameter 0.5 centimeter, and it is assumed that 1/8 space of the cube remains unfilled, then the number of marbles that the cube can accommodated is what? So here basically you have to find the number of marbles that the cube can accommodate it. So let us solve this problem. So first of all, here we will discuss thinking process. Okay, so if we divide total volume filled by marbles in a cube by volume of a marble, then we get the required number of marbles. Okay, so here given age of the cube is 22 centimeter, and therefore the cube of volume of the cube is, we know side cube is actually volume of the cube. So here side is 22 centimeter. That is age of the cube is 22 centimeters. So volume of the cube is 22 centimeter, 22 cube. Okay, that is equal to 10648 semi cube. Okay, so also given diameter of marble, that is 0.5 centimeter. Therefore radius of the marble is r equal to 0.5 by 2, that is equal to 0.25 centimeter. So since we know diameter is 2 times radius, now volume of one marble is 4/3 pi r cube, and here r is equal to 0.25 centimeter. Okay, so this is equal to 4/3 22/7 times 0.25 whole cube. Since we know volume of sphere is 4/3 times pi times radius cube. Okay, so this is equal to 1.375 by 21, and this is equal to 0.0655 centimeter cube. So volume of the cube 1/8 minus 1/8 times volume of the cube, that is equal to 10648 minus 10648 times 1 by 8, that is equal to 10648 times 7 by 8, and this is equal to 9317 semi-cube. Okay, so the volume of one marble is 9317 semi-cube, and fill space of cube is volume of the cube minus 1 by 8 volume of the cube. Okay, therefore required number of marbles is total space filled by marbles in a cube divided by volume of one marble. So the total space filled by marbles in a cube is 9317, and volume of one marble is volume of the one marble is 0.0655. Okay, so therefore 9317 divided by 0.0655, this is equal to 142244. Okay, this is actually approximate value. Hence the number of marbles that the cube can accommodate is 142244. Okay, so number of marbles 142244, that is 142244. Here option number is correct answer. And now let us move to next problem. So in next problem, here we have a metallic spherical cell of internal and external diameters 4 centimeter and 8 centimeter respectively is melted and recast into the form of a cone of base diameter 8 centimeter. Then the height of the cone is what? Okay, so basically we have a metallic spherical cell of internal and external diameters 4 centimeter and 8 centimeter respectively, and this is melted and recast into the form of a cone of base diameter 8 centimeter. Then we need to find the height of the cone. Okay, so let us solve this problem. So first of all, when a solid shape is melted and recast into the form other solid shape, then volume of both shapes are equal. Okay, so volume of the both shapes are equal, and given internal diameter of the spherical cell is 4 centimeter and external diameter of the cell is 8 centimeter. So therefore internal radius of the spherical cell is R1, that is equal to half of the diameter of the spherical cell, half of the internal diameter of the spherical cell, that is 4 by 2. This is equal to 2 centimeter. Okay, and external radius of cell is R2 is equal to 8 by 2, that is equal to 4 centimeter. Okay, so you can see this figure. This is our spherical cell, and here the internal spherical cell radius of the internal spherical cell is 2 centimeter, and the radius of the external spherical cell is 4 centimeter. And now volume of the spherical cell is 4 by 3 pi times R2 cube minus R1 cube. Okay, since volume of the spherical cell is 4 by 3 pi into external radius cube minus 4 by 3 times internal radius cube. Okay, so this is equal to 4 by 3 times pi times 4 cube minus 2 cube, that is equal to 4 by 3 pi into 64 minus 8, and this is equal to 224 pi by 3 centimeter cube. Okay, so we get the volume of the spherical cell is 224 pi by 3 centimeter cube. And now let height of the cone is 8 centimeter. Okay, so diameter of the base of cone is 8 centimeter, and therefore radius of the base of the cone is 8 by 2, that is 4 centimeter, since diameter is equal to 2 times radius. Okay, so according to the question, here volume of cone is equal to volume of spherical cell, and here we find the volume of spherical cell, that is equal to 224 pi by 3. Okay, and we know volume of cone is 1/3 pi r 1/3 pi r square h. Okay, so here r is 4 and h that we have to need. So this implies 1 by 3 phi 4 square times h. This is equal to 224 by 3 phi, and it implies h is equal to 224 divided by 16, and this is equal to 14 centimeter. Okay, hence the height of the cone is 14 centimeter. So therefore the height of the cone is 14 centimeter, and here the option number B is correct answer. Okay, so now let us move to next problem. So if a solid piece of iron in the form of a cuboid of dimensions 49 centimeter by 33 centimeter by 24 centimeter is molded to form a solid sphere, okay, then radius of the sphere is what? So we need to find the radius of this sphere. So let us see how to find it. So given dimension of the cuboid is 49 centimeter by 33 centimeter by 24 centimeter, and therefore volume of cuboid is actually 49 times 33 times 24, and this is equal to 38808 centimeter cube. Since volume of cuboid, this is equal to length into breadth into height. Okay, so here the length is 49 centimeter, breadth is 33 centimeter, and height is 24 centimeter. Okay, so now let the radius of the sphere is r, then volume of the sphere is 4 by 3 pi r cube. Okay, since we know the volume of the sphere is 4 by 3 pi times radius cube. Okay, so now according to the question, volume of the sphere is equal to volume of the cuboid. So here we know the volume of the sphere is 4 by 3 pi r cube, and here we have found the volume of the cuboid, that is 38808. Okay, so it implies 4 by 3 pi r cube is equal to 38808, and it implies 4 times 22 by 7 times r square r cube. This is equal to 38808 times 3, and this implies r cube is equal to 38808 times 3 times 7 divided by 4 times 22, and this is equal to 441 times 21, and therefore r cube is equal to 21 times 21 times 21, and therefore r is equal to 21 centimeter. Okay, hence the radius of the sphere is 21 centimeter. Okay, so the radius of the sphere is 21 centimeter. And now let us move to question number 11. So in question number 11, it's said to us a mason construct a wall of dimension 270 centimeter by 300 centimeter by 350 centimeter with the bricks each of size 22.5 centimeter by 11.25 centimeter by 8.75 centimeter, and it is assumed that 1 by 8 space is covered by the mortar. Then the number of bricks used to construct the wall is what? Okay, so here basically we have given the dimensions of the wall 220 centimeter by 300 centimeter by 350 centimeter. Okay, and we also give the bricks size of the bricks 22.5 centimeter by 11.25 centimeter by 8.75 centimeter, and we have given this information. We assumed here that 1 by 8 space is covered by the mortar. So now let us find the number of bricks used to construct the wall is. So first of all, we divide the volume of the wall except the volume of mortar are used in the one wall by the volume of one brick. Okay, then we get the required number of bricks used to construct the wall. Okay, here volume of the wall is actually equal to length into breadth into height, and we here given the dimensions of the wall. Okay, so volume of the wall is equal to 270 times 300 times 350, and this is equal to 283,50000 centimeter cube. Since volume of cuboid is length into breadth into height, and since 1 by 8 space of wall is covered by mortar, so remaining space of wall is equal to volume of wall minus volume of mortar. So volume of wall is 2835000 4 times minus 28354 times 0 times 1 by 8, and this is equal to 2835 4 times 0 minus 3543750, and this is equal to 24806250 semi cube. Okay, so the remaining space of wall, the volume of remaining space of wall is equal to 24806250 semi cube, and now volume of one brick is equal to 22.5 into 11.25 into 8.75, and this is equal to 2214.844 centimeter cube. Okay, since volume of cuboid is equal to length into breadth into height. Okay, so therefore required number of bricks is equal to 2480650 divided by 2214.844, and this is equal to 11200 approximately. Okay, so hence the number of bricks used to construct the wall is 11200. And now let us move to next problem. So in next problem, here we have 12 solid spheres of the same size are made by melting a solid metallic cylinder of base diameter 2 cm and height 16 cm, and diameter of each sphere is what? Okay, so let us solve this problem. Here given the diameter of the cylinder is 2 cm and radius is equal to 1 centimeter and height of the cylinder is 16 centimeter, and therefore volume of the cylinder is equal to pi times 1 square times 16, and this is equal to 16 pi centimeter cube. Okay, since volume of cylinder is equal to pi times radius square times height. Okay, and now let the radius of the solid sphere is r centimeter. So then its volume is 4 by 3 pi pi r cube meter cube. Okay, so pi r cube. So according to the question here, volume of the 12 solid sphere, this is equal to volume of cylinder, so it implies 12 times 4 by 3 pi r cube, this is equal to 16 pi, and it implies r cube is equal to 1, r cube is equal to 1, and it implies r is equal to 1 centimeter. Okay, therefore diameter of each sphere d is equal to 2 times radius r, that is equal to 2 times 1, and this is equal to 2 centimeter. Hence the required diameter of each sphere is 2 centimeter. Okay, and now let us move to next problem. So here next problem, here we have the radii of the top and bottom of a bucket of slant height 45 centimeter and 28 centimeter and 7 centimeter respectively, and the curved surface area of the bucket is what? Okay, so in this problem basically we need to find the curved surface area of the bucket. Okay, so let us solve this problem. So here given the radius of the top of the bucket r, this is equal to 28 centimeter, and the radius of the bottom of the bucket small r, this is equal to 7 centimeter, and slant height of the bucket L is equal to 45 centimeter, and since bucket is in the form of frustum of a cone, therefore curved surface area of the bucket, that is equal to phi L times capital R plus small r, that is equal to 5 times 45 times 28 plus 7. Okay, since we know curved surface area of frustum of a cone, this is equal to 5 times capital R plus small r times L. Okay, where r is the radius of the top of the bucket and small r, this is radius of the bottom of the bucket. Okay, so now if we calculate it, then we'll get this is equal to 5 times 45 times 35, and this is equal to 22 by 7 times 45 into 35, and this is equal to 4950 centimeter square. Okay, so the curved surface area of the bucket is equal to 4950 centimeter square. And now let us move to next problem. So in next problem, here we have a medicine capsule is in the shape of a cylinder of diameter 0.5 centimeter with two hemispheres stuck to each of its ends. The length of the entire capsule is 2 centimeter. Then the capacity of the capsule is what? Okay, so basically we have a medicine capsule which is in the form of a cylinder of diameter 0.5 centimeter with two hemispheres stuck to each of its ends, and we have given the length of the entire capsule is 2 centimeter. Okay, so let us solve this problem. So given the diameter of the cylinder is diameter of this hemisphere, that is equal to 0.5 centimeter. Since both hemispheres are attached with cylinder, okay, so here the diameter of hemisphere is equal to diameter of the cylinder. Okay, and we have given diameter of the cylinder is 0.5 centimeter, so the diameter of cylinder is equal to 0.5 centimeter. Okay, so therefore the diameter of the hemisphere is 0.5 centimeter, and therefore radius of cylinder r, this is equal to radius of the hemisphere r equal to 0.5 by 2, this is equal to 0.25 centimeter. And since diameter is equal to 2 times radius, okay, so here you can see this figure, and here total length of the capsule is 2 centimeter, and length of the cylindrical part of capsule. Therefore, each of the length of the capsule minus r radius of the both hemisphere, that is 2 minus 0.25 plus 0.25. So now capacity of capsule is equal to volume of the cylindrical part plus 2 times volume of the hemisphere. So we know volume of the cylindrical part is pi r square h, and volume of the hemisphere is 2 by 3 pi r cube. Okay, so we know this formula: volume of cylinder pi radius square times height, and volume of hemisphere is 2 by 3 pi radius cube. Okay, so if we now substituting the values of radius, height, and then we'll get this is equal to 22 by 7 times 0.25 square times 1.5 plus 4 by 3 times 0.25 cube, and this is equal to 22 by 7 times 0.09375 plus 0.0208, and this is equal to 22 by 7 times 0.11455, that is equal to 0.36 centimeter cube. Okay, hence the capacity of capsule is 0.36 centimeter cube. Okay, so now let us move to next problem. So in next problem, here we have, if two solid hemisphere of same base radius are joined together along their bases, then curved surface area of the new solid is what? So student, let us solve this problem. So here, because curved surface area of the hemisphere is 2 pi square, and here we join two solid hemisphere along their basis of radius, okay, from which we get a solid sphere. Hence the curved surface area of the new solid is equal to pi square plus pi r square plus 2 pi r square plus 2 pi r square, that is equal to 4 pi r square. Okay, so the curved surface area of the new solid is 4 pi r square. So here option number A is correct answer. And now let us move to question number 16. So in question number 16, here we have a right circular cylinder of radius r centimeter and height 8 centimeter, where h greater than 2r, and just encloses a sphere of diameter r centimeter, diameter of what? So let us find. So because the sphere encloses in the cylinder, therefore the diameter of the sphere is equal to the diameter of the cylinder. And here we have given the radius of the cylinder is r centimeter. So therefore the diameter of the cylinder is 2 times r centimeter, and therefore the diameter of the sphere is 2r centimeter. Okay, now let us move to next problem. So in next problem, here we have, during conversion of a solid from one shape to another, the volume of the new shape will, in option A we have increase, in option B we have decrease, in option C we have remain unaltered, and in option D we have B double. Okay, so basically, when during the conversion of a solid from one shape to another, the volume of the new shape will remain unaltered. Okay, they'll never change. Okay, so that is actually they are equal. So during the conversion of a solid from one shape to another, the volume of the new shape will be remain unaltered. And let us see now question number 18. So in question number 18, here we have the diameters of the two circular ends of the bucket are 44 centimeter and 24 centimeter. Then the height of the bucket is 35 centimeter. Then find the capacity of the bucket. Okay, so let us solve this problem. So here given the diameter of one end of the bucket. Okay, so diameter of the one end of the bucket is 2 times radius r, that is equal to 2 times r is equal to 44, and this implies r is equal to 22 centimeter. And diameter of the other end is 2 small r is equal to 24, and this implies r is equal to 12 centimeter. And height of the bucket h is equal to 35 centimeter, and since the shape of bucket is look like as first term of a cone, okay, so therefore capacity of the bucket is equal to volume of the frustum of the cone. Okay, and here the volume of the frustum of the cone is equal to 1/3 pi times height times capital R square plus h small r square plus capital R times small r. Okay, now if we substitute these values, then we'll get this is equal to 1/3 pi times 35 times 22 square plus 12 square plus 22 times 12. Okay, and this is equal to 35 pi by 3 times 484 plus 144 plus 264, and this is equal to 35 pi times 892 divided by 3, and this is equal to 35 times 22 into 892 divided by 3 into 2 7 3 into 7. Okay, and this is equal to 32706.6 centimeter cube. And now if we convert centimeter to liter, then you'll get this is equal to 32.7, since we know 1000 centimeter cube is equal to 1 liter. Okay, hence the capacity of the bucket is 32.7 liter. And now let us see question number 19. So in a right circular cone, the cross section made by a plane parallel to the base is A. Okay, so let us see which option is true. So we know that if a cone is cut by a plane parallel to the base of the cone, then we get the portion between the plane and base is called the frustum of the cone. Okay, so here the option number B is correct answer. And now let us see question number 12. So we have, if volumes of two spheres are in the ratio 64:27, then the ratio of their surface area is what? Okay, so let us see how to solve this problem. So let the radii of the two spheres are r1 and r2 respectively, and therefore volume of the sphere of radius r1, this is v1 is equal to 4/3 pi over 5 r1 cube. Okay, since volume of sphere is 4/3 pi radius cube, okay, and volume of the sphere of radius r2 is v2 is equal to 4/3 pi r2 cube. Okay, and given the ratio of volumes, that is v1 is to v2, that is 64 is to 27, and it implies 4/3 pi r1 cube divided by 4/3 pi r2 cube, this is equal to 64 pi 27, and it implies r1 cube by r2 cube, this is equal to 64 by 27, and it implies r1 by r2 is equal to 4/3. Okay, now ratio of surface area, this is equal to pi r1 square by pi r2 square. Okay, so here this is equal to r1 square by r2 square, and this is equal to r1 square by r2 square is equal to 4/3 square. Okay, so 4 square by 3 square, that is equal to 16:9. Okay, so the ratio of the surface area is 16:9. So therefore option number D is here correct answer. Okay, so I stop here this lecture. Thank you very much to all of you.